it's a real honor and pleasure to be able to talk to you about Louis Alvarez, a true giant of the 20th century physics. Oops. Okay, so I was asked in 20 minutes to sum up 60 years of very illustrious scientific career. That's a bit difficult, so clearly I have to use certain judgment and have to be very, very selective. And I'm not going to try to repeat or go over Louis' many outstanding achievements. I mean, we've heard many of them, and I could not possibly compete with some of the wonderful talks that we've heard. So what I would like to focus on is really Louis as a person and some of the qualities that made him such a great physicist. A lot of them have already been said. A lot of that has been already said. You know, some of my thunder has already been taken by several speakers. So there will be maybe a little bit of repetition. But that's basically what I would like to do. Okay, so this is a 100th year anniversary of Louis' birth. And the idea is to have talks by the participants. And that's really wonderful. You get a first-hand sort of telling of the, of all of Louis' accomplishments. But the only difficulty with it is that Louis' career has really started quite some time ago, and it would take 100-year-olds to really be able to give you a first-hand account of that. That actually has been much easier 25 years ago because there are many more 75-year-olds than 100-year-olds. And so what I would like to do is to sort of make an advertisement for this very nice compendium by Peter Trower, which, again, has first-hand accounts by many of Louis' collaborators or people who were very close to the work that he was doing. And I think I would really encourage you to look at it if you want to learn more about what Louis has accomplished. But for the sake of completeness, let me just go through very, very quickly and enumerate some of those early accomplishments by Louis. Some of them have been mentioned, but they really haven't been discussed in great details. So we can have, actually, I like to divide it into three periods, three epochs. The first one being the pre-war years. And so what are some of the things that Louis has done, either discovered, invented, or seriously contributed to? Where there is the east-west effect with cosmic rays, one of his first works. K-electron capture, that you have already heard about. There is the mass 3 problem. I mean, was it the helium-3 or hydrogen-3 that was the stable one? There was the length standard from the mercury isotope that replaced the existing one. There was the artificial radioactivity, neutron magnetic moment that you have heard about. And then, as Louis told many of you, and he certainly told me that, about things that he just missed, okay, the fission and the slow neutrons from fission. And the interesting thing was that he learned lessons from that. I mean, you know, what to pay attention to and things like that. There were the war years, and those years that Louis spent first at the MIT working on the radar. You've heard from Rich already about the Vixen. I think that's a wonderful story because it shows the simplicity of some of Louis' ideas and how you can apply those to very, very complex problems. There was the microwave early warning system. There was the ground control approach, the trigger design for the plutonium bomb that you've heard about, and then he was in the observer plane for the Hiroshima bombing and previously developed actually the instrumentation to get information on that. So it was first MIT, then England, and then finally Los Alamos. Okay, then there was the early post-war period. He came back, as you've heard, to Berkeley, became a graduate student of Lynn and Frank and Bob. And one of the first things he did, he built the proton linear accelerator with Piv Panofsky, okay? And I like to refer to that as experimental physics dream team, okay? You couldn't really think of two, more ingenious experimental physicists. Also, the fact that he used the radar tubes for that also illustrates one of Louis' characteristics, the ability to take something, whether it's information or physical hardware, from one area and move it to somewhere else. He actually was the first one to demonstrate the strong focusing principle after it was predicted at Brookhaven. And then, as already was mentioned, he had independently basically conceived and constructed the tandem Van der Graaf accelerator. Okay, all of those, basically leads to what I would call Alvarez version of the Shakespeare-type dilemma. Okay, where the question was, how could one man have written all of those works? And so I would ask the same question that Rich asked earlier today. How could one person have accomplished all of that in one's lifetime? But we know that Louis did it. Okay, so therefore, what I would like to talk about, what were the guiding principles in his career and what they teach the next generation and so on. What was it that made him so successful and allowed him to do so many significant things? Okay, but first, maybe I should mention how he got into physics. So again, let me give some quotes. Unfortunately, some of them already were done, so it sort of spoils my play. But anyway, here are some that basically physics, yes, chemistry, no. Louis took some chemistry courses before actually he took physics courses. And here are some comments. The chemical laboratories were repulsive, filled with hydrogen sulfide fumes. I hope you know how hydrogen sulfide smells. Okay. Besides enduring the stenches of formaldehyde, benzene, and other pungent compounds, I never produced anything in my test tubes but a succession of black, gooey residues. And then the 5 courses that he took, apparently he got Bs, and he said, I couldn't stand the idea of being a bee chemist. I imagined with horror a lifetime in chemistry. Okay, and then, to give you a contrast, I discovered physics as a junior at the University of Chicago. It was love at first sight. Okay, so now let me talk a little bit about Louis' own view of himself and his introspective. He really had an uncanny, I would say, in retrospect, ability to really evaluate his strengths and weaknesses, or things that maybe he didn't do quite right, and learn from that particular experience. So let me talk a little bit about that, and that is based partly on the wonderful autobiography that he wrote with Peter Trower, that Louis was kind enough to give me an autograph copy of. So I've drawn on that and also on my own personal experiences with Louis during my stay in his group. So here are some comments about his ability to self-analyze and self-criticize. Okay. First of all, he said, by almost any standard, my training at Chicago has been atrocious. Okay, he was not very complimentary to basically the training he got, but also partly it was because it was in a very different field, as he mentions, as it's stated in these quotes, my experimental skills were largely outmoded. I mean, he was a great machinist, glassblower, and these kinds of things. But I knew almost nothing of nuclear physics, radioactivity, RF engineering. And then this is a comment he made after one experiment he did, that he missed something very, very fundamentally, that he should have been more observant. And he realized that, and that really, really affected, his future. I mean, he was always very, very careful about trying to make those observations. Okay, I was too stupid to notice an obvious physics fact. Okay, but also, he was able to appreciate his very, very powerful and strong positive qualities. He says, I could build almost anything out of metal or glass, and I had the enormous self-confidence to be expected of a Robinson Crusoe who had spent 3 years on a desert island. I think the reference to Robinson Crusoe is because, as he told me, it's also in his book, he was a student of Arthur Compton, and during his 3 years, or 4 years, whatever it was, as a graduate student, Compton came to his lab once. Okay, so he really was a Robinson Crusoe. Okay, the only way that I could really learn nuclear physics, I concluded, was to read everything that had been written on the subject. He knew he had to know nuclear physics when he came to the Red Lab, okay, but his knowledge was inadequate. I brought from Chicago an intense curiosity about how everything worked and where everything was. And finally, I wasn't interested in adding yet another pedestrian radioactivity to the increasingly dull list, that kept being discovered all the time at the Red Lab. I wanted to accomplish more interesting original work. So if you read these 4 statements, what I see here, basically 4 pillars of Louis' success, starting from the top: confidence, knowledge, curiosity, and an excellent taste in physics. And I would add to that maybe one more, and that is the ability to connect the dots, the ability to basically utilize the knowledge in one area to do experiments and to learn and to investigate in another area. Okay, part of his introspective was to really evaluate what he was good at and what he was not good at. And that's sort of advice that he gave to people, try to find out and do what you are good at. And here are some quotes from him. The world of mathematics and theoretical physics is hierarchical. There is a limit beyond which one cannot progress. And he felt that he probably would have reached that limit earlier than a lot of other people. The shock that a talented man experiences when he finds late in his academic life that there are others enormously more talented. If I had decided to become a professional mathematician, I would have made the traumatic discovery that there are many people my age who are far more talented mathematically than I could ever be. Okay, this, I think Bob Bergenau already mentioned that, the advice, but let me maybe still put it up in case some of you were not here earlier today. As you know, Walter Alvarez, Louis' father, was an outstanding scientist in his own right in the medical field. And this is the advice he gave him: to sit every few months in my reading chair for an entire evening, close my eyes, and try to think of new problems to solve. Okay, and this is something that Louis really followed, really try to assess, what's happening in the world of physics, what are the crucial problems, and how he can contribute towards solving them. Okay, Louis was actually very fortunate in, coming to Radiation Lab, and there were a lot of very, very positive things at the Red Lab at that time. The milieu was very, very conducive to doing excellent physics. Let me just mention some of them. Okay, the first of all was really a hotbed of nuclear physics, but also accelerator development, which allowed you to probe higher and higher energies. It was relatively unencumbered by many regulations, and I'll have more to say about that in a moment. There was a very highly cooperative spirit among the researchers. First-class theorists on Berkeley campus. This was important because quantum mechanics was just in an infancy, and so was really nuclear physics at some level. And finally, what was mentioned many times was the journal club every Monday evening. And thinking back about my own career, I think I came to the Red Lab about 25 years later or so, and essentially all of those characteristics were there, or almost all. Maybe it was not as highly cooperative spirit. I think it was within Louis' group, but between different groups, I think it was competition maybe was more frequent than cooperation. But certainly Bevatron was the leading accelerator at that time, and still, when I came at least, there still was no program committees, and a lot of theory, and of course the journal club at Louis' house. Okay, so let me maybe talk a little bit, give you 2 anecdotes about the ESNH in the 1930s in the spirit of this reduced red tape. Okay, this is actually from Chicago during his graduate career. I used a very bright mercury vapor lamp, which I built with the help of a friend. In use, my lamp would blow up and spray mercury droplets all over my basement room on the average about once a day. Mercury in the cracks of the wooden floors of physics research rooms was not then considered a hazard, but it was accepted like ants at a picnic. Okay, here's another one, another anecdote. Joe, I think it was Joe Hamilton, this is in the days that people were just getting interested in using radioactive isotopes for the diagnostic purposes in medicine. So Joe asked me if I would collaborate on an experiment to measure the rate of absorption of sodium ions from stomach wall into the bloodstream. He proposed that we drink a millicurie of sodium-24 while holding a Geiger counter and watch the counting rate increase with time as the blood flows that way. Joe did the experiment first on himself. I became the second guinea pig. It was the first experiment of this kind. Okay, a pioneer again in another area. Okay, on the other hand, I don't want to imply that Louis was in some sense an ESNH. Incidentally, if you don't know, ESNH is environment, safety, and health, okay, that those of us working in physics today certainly know about. But that rather that there's something indicative of the time, because certainly the bubble chamber work, Louis imposed the most rigid safety standards around the bubble chamber. He knew the potential danger, and he was determined to avoid it, and you've already heard, one incident of that. And so he was, after many years as the head of the group, he was retiring, and a new head was about to appoint it. Somebody asked Louis about what does the person do, what are the responsibilities of that person. He is the person who talks to the widows after an accident, was Louis' response. So Louis took it very, very seriously. Okay, here's how he felt about red tape. If someone wants government support today, he first has to write a lengthy proposal. Committees then judge his proposal. In the unlikely event that the proposal is accepted, it has to be worked into budgets that measure their time frames in years. We waste far greater sums of money on bureaucratic review, delay, and red tape than we could possibly lose if a project occasionally failed. In the process, we squander the enthusiasm of the originators, which may be even a greater loss. I remember when the first Program Advisory Committee, PAC, was formed at Berkeley to talk about the Bevatron schedule. There were a number of theorists on it. And Louis' comment, I remember having a conversation with him about it, says, well, when are we going to form a committee telling the theorists which theories they can work on? Okay, Louis' spectroscopy was Louis' first love. And I think it remained, one of the fields that he really enjoyed very much. And I think a lot of the industrial optics were sort of, maybe a reflection of his love for the field. I mean, this is what he wrote early in Chicago, that measuring wavelengths was the most exciting work I had ever done. The joy I felt in working with this beautiful instrument, and so on and so on. And my first scientific love, the optical spectroscopy. I remember when the laser was discovered, okay, and Louis read it in Physrev letters, and he came to the graduate student bullpen, which was close by his. I happened to be sitting by the door, and he showed me the article, and he was really, really excited, because spectroscopy was really backwaters already by that time. And he says, look, this is really going to revolutionize spectroscopy. And you've already heard from Stewart, the two-photon thing. There was sort of one example of the kinds of physics, kinds of experiments that you could do, which were not possible before. Okay, now this, a lot of you talked about Louis being a visionary. Let me just graphically show you the example of that in the area of bubble chambers. Here are the here is the first tracks, or some of the first tracks in Dunn glazers, 1 centimeter long, and I think it was diethyl ether and so on. And so when Louis saw this, even though it was produced by chambers like that, okay, little glass tubes. It was believed at that time that it was important to keep the chambers clean, no interfaces between metal and glass, because that would create an area where bubbles could start forming and the liquid could start. But anyway, so then when he saw that, he already conceived the 72-inch bubble chamber. Here it is. And also anticipated beautiful pictures that you could see that, again, would revolutionize the area of elementary particle physics at that time. Louis was very fond of relating the story, okay, how he wanted to build the 72-inch bubble chamber when only 4-inch chamber existed at that time. And so he went to Lawrence and, asked him for support to get $2 million, okay, this princely sum from AC. And Lawrence was very, very skeptical, apparently. And he said that 72-inch was too large as an extrapolation from 4 inches. He says, I don't believe your big chamber, he told me, but I believe in you. And then he supported Louis, and Louis, as we all know, got the money to really build this device. Finally, I want to say about Louis the educator. Some of you may know that his first publication was actually in a scholastic journal, the Journal for Teachers, a simplified method for determination of the wavelength of light, okay? And again, characteristically, Louis, and this is, I guess he was 20 or 21 then, he used a broken phonograph record as a diffraction grating, an electric light, and a meter stick, and projected on the wall. And that was it. 1 year, I remember, I think I was just a first-year postdoc, Louis was teaching an introductory physics course, and he had to be away, I think, a couple of times. So he asked me to give his lecture and suggest that I come before to hear his lecture. And, I was just tremendously impressed how he didn't just go through the book, but really try to make the physics alive and gave, common examples and really made it fascinating. And, of course, the bad thing for me is I couldn't possibly reproduce that kind of style on the following lecture day. Okay, finally, a comment by Feynman. Again, I think Moish already said that. The point is, if Alvarez was on this commission, he would do it, and that's good enough for me, for Feynman. And as hopefully most or all of you know, Feynman is one of the heroes for the physicists, and this kind of an endorsement, anyway, one of us would really be very, very flattered and pleased by. So let me end by actually a quote that I wrote in Peter Trower's book 25 years ago that ended up actually on the jackets. Louis was emphatic about the need for curiosity and for constantly striving to understand new techniques. He contrasted trying to become a good physicist with trying to become the president of General Motors. The latter was a political task requiring great care not to offend people, while the most important ingredient in becoming a good physicist was curiosity. And then he goes on about snooping and so on. To me, Louis remains a first-rate model of superb scientist whose extensive interests in a variety of problems are only matched by his ability to use his ingenuity to attack and find solutions to those problems. But above all, because of his great impact on my career, I most remember him as a superb teacher and a good friend. So I would like to end here. Maybe before we break up, what I would like to do, since I'm the last speaker, is I'm sure on behalf of everybody here to really express sincere thanks to Lina Galtieri and the whole organizing committee for organizing this wonderful symposium.